Welcome back. So in this welcome back. So in this next lesson, we're going to build on the previous example where we created a moving agent using vectors, and we're going to expand on this by creating this idea of a particle system. Or in other words, we're going to have a framework for creating lots and lots of agents, keeping track of them and updating them over time. And you'll see we're going to do this in the simplest way possible. So let's just dive right in. So I'm starting here from the code example we had in the previous lesson. So what I'm going to do is remix my own project so I can start something new here. Okay. And let's give this project a name. We're going to call it Group of Agents. Multiple objects. Okay. All right, so there's lots of examples out there on how to create what's often usually referred to as a particle system. The idea, it's called particles because you're going to have lots of small objects, or they don't have to be small, but lots of objects kind of part of the same framework, and they're going to be updated in the same way. They're usually going to share the same behavior, and they're going to be sort of moved and updated together. So at its core here, what that means is that we need a place to be able to create and store multiple of these agent objects. So a particle system can be as simple as an array. Okay? Doesn't have to be fancy. We just need a place that we can store all the objects that we're going to be creating, so that over time we can track their position, velocity, acceleration, and then we can also update them and move them independently. So all this has to be is basically just an array. And instead of having a single agent here, this single variable, we're going to create agents over time. So let's do this in, so first I'm going to delete this single variable. Don't need that guy anymore. Instead, what we're going to do is, for this example, we're going to create more objects over time in draw. And we're going to do that when the mouse is pressed. So in P5.js, if you want to know if the mouse is pressed, you can use a built-in variable called mouse is pressed. So if mouse is pressed, this is a Boolean variable, which means it's checking if it's equal to true. But because it's a true or false value, we can actually omit that part and just put the name of the variable inside the if statement. So we'll say if the mouse is pressed, we're going to create a new agent variable. It's called new guy. And so this is going to be created using our createAgent function that we made up here. So this is going to return, right, an object which is going to contain a position, velocity, and acceleration. Now, it would be good to give this object some starting conditions. So we have a few options here. We could give the object just parameters right here. So for example, if you want this variable, maybe this object is going to start in the center of the window, for instance. We could do it like so. We could start modifying our variable's internal objects. Or we could also add some parameters to the createAgent function. However we choose to do it, it's up to us. Just to demonstrate here, we're going to add a few parameters to this createAgent function, because right now it's a bit limited. It always creates objects at 0, 0 with no velocity and, of course, no acceleration. So let's add a few parameters. We'll put in xy, vx, vy for position and velocity. So when we create the position vector, we'll pass in x and y. And when we create the velocity, we'll pass in vx and vy, like so. So now we can provide these variables when we first create the object. So maybe we'll say put it in the center of the window, and then the velocity could be a random number between -1 and 1 for both the x and the y coordinate. I put that on a new line so we can see it a little bit better. Okay. So now we've added some parameters here. If we wanted to have it both ways, we could also put in some default values for these parameters. We could say if you don't provide x, y, and y, we can say the default, could be just they're all set to 0. Okay? So if we now we have the option to use createAgent with or without parameter if we want. Okay. So what we're going to do is we're going to take this new variable we made and we're going to add it to our group array. So we'll say group.add new guy. And then in the other bit of draw here, we no longer have to move one single agent. Now we have a whole bunch we're going to be adding into this group variable. So we're going to set up a for loop that's going to iterate over everything we've added to this group. And we'll say for every agent, right? Let agent for group. Oh, sorry, of group. We're going to say move that agent. Let's say, let's get rid of the follow the mouse for now because it's going to get a little bit confusing. We'll say move that agent and then render that agent. Oops, I made a mistake here. So it's not group.add, it would be group.push. Okay. All right. Now, this is hard to see here what's happening in part because we have our damping variable. So let's make the damping equal to 1 so the objects no longer stop here. So when I press the mouse, we can see we've added a number of these agents. So in every frame, as long as the mouse is pressed, it's going to create a new one. That object then gets added to the group. And then in draw, we just iterate over the group array and update, render all the agents. Create new agents over time. All right. So now that we have lots of these guys, we are going to update our render method a little bit, just because it's getting a little bit hard to see. We're going to make these a little bit smaller. So instead of a square here, I'm going to make a small rectangle. Actually, the other way. I want it to be wider and shorter. Okay. And this is still a little bit big. Let's make it even smaller. Okay. All right. So now we have our agents. Now, a particle system can be as simple as this, right? All we're doing is saying create more of these objects over time that we're creating here using our createAgent function. Take this variable, save it into an array, and then that's it. This is our particle system. It's basically an array of objects. Now, obviously, this is a little bit too simplistic. One of the problems with this right now is that as we create more objects over time, our group array just gets bigger and bigger and bigger. It just never ends. Eventually, these objects, they're just leaving the window, for example, right? So we're not seeing them anymore, but they still exist. We could see this if we had at the end of draw here, let's just add the number of active agents. We're going to set a fill of white, and then we're going to draw using text. We'll say group.length, and then we're going to draw this at, let's say, 2020. Okay. So this is just a number here that's going up. But we can see that as I'm adding, you see the numbers over here. It's a bit hard to read because of the stroke. Let's disable the stroke. So we start out with 0 agents, of course, and then as the mouse is pressed here, we're creating more. They get added to the group array, which in turn has its size increasing over time. So if we create lots and lots of these, right, we can see that this number is not going down. So after a while, this is going to start to become a bit of an issue when we start to have thousands and thousands of these objects that we're animating and drawing and moving in Draw here, even though they may not even be in the screen anymore. So let's talk about how we could improve our group of agents a little bit more by doing a little bit of house cleaning. And we could start by saying, whenever one of these objects leaves the canvas, maybe we'll just get rid of it. Okay? So whenever they move out of sight, let's have a way of just deleting them so that we just don't keep accumulating objects over time forever. So we're going to create a function here that's going to allow us to tidy up, do some house cleaning and get rid of extra agents we don't want around anymore. We're going to call it cleanup. And the parameter to that function is going to be group. So the first thing we're going to do is, in order to clean up, we need to iterate over the array. So we want to be able to look at every one of these active objects and then decide, is it time for you to go? Should we delete that object? So we're going to write a for loop here that's going to use I to count through every object we have in the array. Now I can't use the this syntax of for loops here, right? The shorthand syntax where we just count using objects. We just iterate using objects, and that's because in JavaScript, in order to remove an object from an array, we need to know its index. So we're going to have to generate the series of indices that represent every element in our array. So inside that for loop, we're going to have to make the decision: do we need to delete this object or not? So, for example, like we said, we could decide that we want to get rid of these agents once they leave the window. Okay? So we can think of our window as a box, right? It's a rectangle, and the question we want to be able to ask is one of these agents inside the box, right? Is it in the window or is it outside the box? And we can do that pretty easily with an if statement. So we could say, first, because I don't want to have to use brackets all over the place, let's extract the variable we're interested in using this line here. So we're going to say, yes, I know, we will use that value. Let agent equals group I. Okay? I do this because I find it annoying when working with arrays, sometimes having to always use just brackets all over the place. It's makes things a little bit harder to read. So how do we ask the question if this agent is contained when inside the box that's defined by the window? Well, that's actually a pretty easy question to ask. If we know the size of the box, which we do, it's the window, right? It starts at 0, 0, and it's the width and height of the window. We have access to those, and we know the position of the agent. We know its we know its coordinates. We could ask the question by saying, is the x value of the agent, right? So if we look at it on the x-axis, if the x value is both greater than the left edge and smaller than the right edge, we're inside, and if it isn't, we're outside. And we do the same thing with the y coordinate. Now there's going to be an if statement that we're going to write this to ask that question, and for the sake of clarity, we're going to package this as a function as well, just so we don't clutter our for loop too much here. So let's create a function that's going to ask the question, is an agent inside a given box? Okay. So the first parameter will be an agent. Then we'll say, what is the x, y coordinate, and then what is the width and height of this box? So for simplicity here, let's extract that agent's position and put it into these variables with short names, just to make the if statement we're about to write a little bit easier to digest. So we'll say if the x position of the agent, right, is greater than the x position of the box, and, so if you remember, this means and, the double ampersand, and the x position of the agent is smaller than the right edge of the box, which is x plus w, and if the y position of the agent is greater than the y coordinate of the box, but also at the same time smaller than the bottom of the box, which is y plus h, if all of those things together are true, then yes, the agent is in fact inside the box. And if any one of these is false, it isn't. Okay? So now we have a function where we can ask the question, given an agent and some dimensions here, is that agent inside a particular rectangle or a particular box, or is it outside? So back to our cleanup function here, we're going to say if, right, is agent inside box, and then which agent, well, it's going to be this variable here. And then what is the box? Well, we could start by saying 0, 0, width, height. Those are the dimensions of our window. So if that's the case, we want to get rid of this agent. Okay, that means that agent is now outside the frame, and we want to get rid of it. So the function to do this on arrays is called splice. So splice takes two parameters. The first parameter is the index of the value we want to remove, and then the second parameter is how big of a chunk do we want to take out of the array. So if we're only interested in removing one object at a time, I'm going to put 1 here. It's going to say remove one object starting at index I. With splice, you can actually cut bigger chunks of an array. If we put in 10 here, it would actually remove the object at index I and then 9 others afterwards. But that's not what we want to do here. We just want to remove that one object. All right. Now I just noticed here we're actually asking the wrong question. So if the agent is in fact inside the box represented by the window here, we don't want to get rid of that agent. We only want to do this if the result is false. Okay. The other thing we need to do as well is we've written this function cleanup, but we're not calling it yet in the code. So we also have to do that. So after we're done moving our objects here, we are going to get rid of dead weight. We're going to say clean up the group. So let's see what happens when we do that. So now I'm just creating a whole bunch of agents, and then we should see something happen over time. We should see this number go down. Now, if we're paying close attention, you may notice it's not always the correct object that's going to be disappearing. Okay? And the reason for that is because we have to be really careful whenever we remove objects from arrays. If we look at this for loop here, what happens when we splice from an array? So when you say go at this index, yeah, and then kind of take an X-Acto knife, cut an object out, what's going to happen is the array is going to shrink. Okay? So the next time the for loop repeat, group.length is going to be 1 less than it was before. So that's going to throw off our whole index sequence. If we end up deleting a whole bunch of objects as we iterate, when the loop continues, this array is now shorter, okay? Which means there might be some objects we never visit as a result, or we might remove accidentally some other objects that we want to keep. So the way that we work around this, generally in JavaScript, whenever you have a situation where you want to remove objects from an array while you're iterating, is we're going to just turn things around. We're going to count backwards. And in this way, we're going to start with at the end of the array, so that if we remove objects as we go, it's not going to matter that the array is shrinking. And the way we do this is very easy. We're going to just change the way we write this for loop here. We're going to flip it around. Instead of counting from 0, we're going to start at group.length -1. Okay, the -1 is really important because remember, group.length is the size of our array, and the last index is actually -1, that value. Then the condition is going to be as long as I is greater or equal to 0. Okay? And then we're going to count down. We're going to count using -, instead. So this loop is doing a similar job, except instead of starting from the beginning, it starts at the end and then it counts its way down towards the beginning of the array. The other thing you may notice if you observe what's happening here when these objects disappear is that some of them appear to just kind of pop out of view, right? And that's because we've created our box as literally the window size. And we draw our objects from the center, remember. So they have a size, they also have a size. So what we might want to do is extend this boundary a little bit that we're using to test whether or not to keep an agent, so that an object has time to kind of move off frame a little bit before we delete it, just so we don't have this jarring effect. Sometimes it just looks like they're disappearing. The way we can do this is we're just going to change how we ask the question here. Is an agent inside the box? And we're going to say, instead of 0, 0 width and height, let's define a zone that is, I don't know, arbitrarily -50, -50. So we're going to make it up here in the corner. And then +50 or +100 for the dimensions. Okay. So what this is going to accomplish is kind of create a slightly bigger box than our window actually is for the purposes of testing, right? Should the particles be, or should the agents be deleted or not? So we'll have a slightly smoother transition here. We're going to delete them when they're actually off screen instead of the second they touch the border of the window. So another concept we can add to this this group of agents, right, is we can think about, we can give a sort of expiration date to all of these objects. What I mean by this is we're going to give them a lifespan. Okay? It's a bit of a metaphor for saying how long do we want these objects to stick around, and that could be interesting also. Instead of just getting rid of them when they leave the window, we could also give them, you know, a finite life, a certain number of frames that are going to be allowed to live. And then this way we can also kind of keep the number of objects manageable that we create within a given sketch. So that's going to be an example of adding an attribute to our agents. And those attributes could be anything. We're just making this up as we go. So we're going to add lifespan, but down the road we could add other attributes like size or a color or something else. Okay. So what's a lifespan? Well, it could just be a number, right? We could say, let's create every object with a life expectation of 300 frames. You know, it's kind of, oops, not a semicolon, a column. And then what we're going to do is over time, when we move the object, right, after we're done moving the object, we could also shorten that object's life by just subtracting from lifespan. So we're going to start at 300, and then every time that object gets drawn, we're going to take away from its lifespan. And then in our cleanup function here, we could expand on this if statement here. I'm going to open my window, make it a little bit bigger. Let's go on a new line to make it a little bit clearer. We're going to add this symbol. Remember, the two lines here means or. So we're going to say if an agent is inside, right? If it's inside if inside the box is false, right? If it's outside the window, or if the lifespan is equal to 0, or to be safe, let's say smaller or equal than 0, just in case down the road we subtract more than 1 from the lifespan. Okay. Then we get rid of that agent as well. So now we're going to have some objects that are going to just disappear before they have a chance to reach the edge, because their lifespan has expired. So depending on their speed here, there's now two potential things that could happen for us to get rid of an agent. It leaves the window, or it just ran out of time. Its time is up, so we get rid of it. I know it's pretty ruthless, but you know, these are metaphors. And there's some interesting things we can do with the lifespan. For example, we're gonna, in the next lesson, we're gonna talk a little bit more about, now that we have this system of agents that are moving, you know, what could we do? How could we turn this into a drawing machine? But for instance, you know, with the lifespan, we could do some interesting things in the draw command here. You know, we could set an alpha value based on the lifespan of an agent. Maybe we'll map the lifespan, which is between 0 and 300. We're going to map it to a number between 255 and 0. And then we'll set that to be the stroke alpha value. Actually, let's do the other way around, 0 to 255. So that the agent fades as its, as its life is running out, for example. So that can be kind of nice. So we can use that value, and we'll do some examples of how we can do that in the next lesson. So the lifespan attribute just gives us, it gives us a way that we can call the agents, get rid of them over time, so we don't have too many at once, because that can make our sketch really, really slow if we have thousands. And then we can also use that value to do other things in our drawing code, for example. So now we have a particle system. Let's add a few more behaviors to these agents. For example, we could apply a force like gravity, so that over time their movement would droop towards the bottom of the screen, for example. So let's program this as a new function. So we'll say, let's call this function applyForce. So the idea here is we're going to be able to take an agent and then apply some kind of vector force to it, some constant vector. So if we're talking about gravity, it would be a vector that's pointing downwards, right? Or if we would want to have wind, we would have a vector pointing to the right, and we would just add this over time, always the same force kind of pushing our objects in a direction. So what does it mean to apply a force? Well, it's pretty simple, really. We could say, just take the agent's acceleration value, right? And then add this force vector to it. And then if we wanted to, we could introduce the easing idea. We put into follow the mouse as well. For now, we'll just leave it simple here. Apply force, it just means add a force to the acceleration of an agent. And then as a global variable up here, let's call this force gravity. We're going to say gravity will be a new vector, and that vector is going to point down. So just a new vector object, and then it's going to have a 0 on the x and then 1 on the y, which means it's pointing downwards. We'll probably come back and make that number smaller, but let's just start with that. And then in draw here, we're going to move the agent, then we're going to apply a force to the agent called gravity, and then we'll render the agent. So now we can see that we have this force pushing down on our objects, and gravity is pretty intense right now. So let's turn it down a bit. Let's make it 0.1. Still a bit much. 0.01. Okay. But again, it doesn't have to be like super realistic or anything like that. We're just kind of adding the ability for these objects to fall down. Another interesting behavior, we could add at this stage, maybe we want to also randomly affect their motion, maybe change the rotation of an agent after it's being created, just maybe to make them a little bit more twitchy or make them work in more interesting ways, move in more interesting ways. So every time we want to create one of those behaviors, we can just think about writing a new function. Let's think about this. Maybe we'll get them to, let's call this one twitch. So we're going to make our agents a little twitchy. And the way we're going to do this is we're going to take advantage of the fact that our agent's velocity is a vector, and we can rotate that vector a little bit if we want to. So we're going to say agent.velocity.rotate, and we're going to rotate by a random amount. Let's say random between nothing and tiny amount. Remember, these are in radians, these angles, so a little goes a long way. And then in draw, not only are we going to apply a force, we're also going to get our agent to twitch. So now they're getting a random rotation applied to them, always in the same direction, because we're going from 0 to 0.02. Or we can make this negative. See what happens if we do that. So now they have a path that's, a little bit less of a straight line. So now they have some twitchiness to it. And of course, if we increase that number, we could also increase the amount of twitchiness quite a bit. Okay, so those are just examples of how, now that we have this ability to create moving objects and then lots of them at once, right? We can sort of build in that framework fairly easily by, just our imagination is the limit here to as far as these functions go. So we've done a few examples beyond the basic motion and rendering. We've created a function to get them to randomly rotate, and then we're applying this constant force we're calling gravity, which is just a downward acceleration that we're adding in every frame. So because the theme of this lesson series really is about generative art, now that we have this framework, what we're going to do in the next lesson is we're going to talk about strategies we can use to then start turning these moving objects into artworks, into drawings. And we're also going to give ourselves some control over some of these parameters in our simulation using the user interface, using that GUI, so that we can experiment a little bit more directly with changing the values to see what happens when we do. So I'll see you in the next lesson.